All right, rational equations day 2. So we're going to do some more practice on some rational equations, and hopefully if you got confused after the first day or after practicing class, then you will hopefully get a little bit more understanding after this video. All right, so the very first thing we want to look at is an example 1 is this. 1 over n squared plus 4 over n equals 3 over n squared. So yet again, first thing you want to do is figure out what is my common denominator, and it is going to be n squared, because we have not only one n, but we actually have n squared underneath two parts of the fraction. So knowing that that is our common denominator, the first one doesn't need anything. The second one needs an n on top and bottom, because remember, to get n squared, it's n times n, and then the last one doesn't need anything. So our fraction is now 1 over n squared plus 4n over n squared equals 3 over n squared. So now we want to multiply everything by n squared on both sides to cancel out all of our fractions. So we have 1 plus 4n equals 3 minus 1 on both sides. So then we get 4n equals 2, divide by 4, n equals 0.5 or 1/2. Hopefully you see that while it looks a little intimidating, it's actually not that bad. It's not too difficult. All right, let's look it up. Example 2 is going to be 1 over k squared equals 1 over 3k squared plus k plus 5 over 3k squared. So now, yet again, we need to identify our common denominator, which is going to be 3k squared. The only thing that's missing any pieces is the very first fraction, so times by 3 on top and bottom. So 3 over 3k squared equals 1 over 3k squared plus k plus 5 over 3k squared. Times everything by 3k squared, and it gets rid of all the denominators. So 3 equals 1 plus k plus 5. So then we want to combine our like terms. 1 and 5 is 6. 3 equals 6 plus k. We want to finish solving that. We're going to minus 6 on both sides. K equals -3. All right, example 3, I'm going to write on the whiteboard, and then I want you to try it on your own. Pause the video and try it, see how you do, and then check your work. So it's x minus 5 over x squared plus 1 over x equals 6 over x. So go ahead and pause the video and work this out and see how you do. It is a fractional answer. I'll go ahead and tell you that. All right, look over the work and see how you did. Hopefully you figured out that your common denominator was x squared, and both your second and third fraction were missing that x on top and bottom. So then we got our new fractions in the burgundy, multiplied everything by x squared to get rid of our denominators, and then we just have to solve our fraction, and we get -5/4 as our answer. Hopefully this is making a little bit more sense to you, and it's going okay. All right, looking at the second type of problem that we had from yesterday's lesson. Example 4. 4 over x plus 1 plus 1 over x plus 1 x minus 6 equals 1 over x minus 6. So yet again, the first step is to always identify your common denominator. So it will be x plus 1 and x minus 6. So x plus 1, x minus 6 is your common denominator. And we need to figure out what each set of fractions is missing. The first one is missing x minus 6, top and bottom. Second one isn't missing anything. And the last one is missing x plus 1, top and bottom. All right, so let's write out what we have. 4 times x minus 6 over x plus 1, x minus 6, plus 1 over x plus 1, x minus 6, equals 1 times x plus 1 over x let's keep that in the same order. X plus 1, x minus 6. Now we want to times everything by x plus 1, x minus 6, so we don't have to keep writing it. So that crosses out. All our denominators are gone. 4 times x minus 6 plus 1 equals 1 times x plus 1. Now we want to distribute everything. Okay, so we get 4x minus 24 plus 1 equals 1x plus 1. Combine our like terms. 4x minus 23 equals x plus 1 minus x on both sides. And solve. So 3x minus 23 equals 1. Add 23 to both sides. So 3x equals 24. Divide by 3. X equals 8. So while it looks like a long process, it really is not too bad to get to our final answer. All right, example 5. We're going to work out one more together, and then I will have you try one on your own. 5 over x plus 1 equals 6 over x plus 1, x minus 3, plus 1 over x minus 3. All right, so our common denominator is x plus 1, x minus 3. And then, so the first set of fractions is missing x minus 3 at top and bottom. Second one's not missing anything, and the last one's missing x plus 1 top and bottom. All right, so we have 5 times x minus 3 over x plus 1, x minus 3 equals 6 over x plus 1, x minus 3 plus 1 times x plus 1 over x plus 1, x minus 3. All right, so then we can times the whole thing by x plus 1, x minus 3. That way we can get rid of all the crazy fractions. 5 times x minus 3 equals 6 plus 1 times x plus 1. We can distribute. And once we distribute, we get 5x minus 15 equals 6 plus x plus 1. Combine our like terms. So we get x plus 7 on the right. 5x minus 15. We want to minus x on both sides. 4x minus 15 equals 7. Add 15 to both sides. 4x equals 22. Divide by 4 on both sides. And x equals either 11 halves, or if you want to write it as 5.5, that is fine as well, because it is a nice, pretty exact decimal. All right. Now the next one, I want you to write it down on your paper and try it before watching my solution. Example 6 is going to be 1 over x minus 5 plus 1 over x minus 5, x minus 2 equals 6 over x minus 2. Pause the video and try this problem and see how you do with the final solution. It is a fractional answer. Okay, hopefully you got 29 over 5 and you are looking through the work and seeing if you made any mistakes or have any questions. Make sure you bring them to class tomorrow. You are going to be doing some more practice on this, and hopefully you are doing okay with it. And if you have questions, you can get them answered in class. Have a good